I'm super excited to be here today to present this for you guys. I guess they don't get a lot of external presentations at Linaro Connect, so I'm an external presenter, which is cool. It's not only my first time presenting at Linaro Connect, it's my first time being at Linaro Connect, so I'm super happy about that. So, get going. This is my presentation from zero to zero copy and how you can improve your media player. So, not a lot of people know who I am. I'm very welcome to have people come and talk to me after. My name is Lucas Rusak. I'm actually living in BC, and I work on this kind of like in my spare time. I'm actually a control systems engineer by schooling, so yeah. So this is kind of what we're going to go through today. This is kind of just meant for people reviewing the slides, but we'll go through it quickly. So what is zero copy and what does it mean in terms of video playback and video rendering? So ideally, we want to be able to take some data, put it in a buffer, and leave it in that buffer until it's used and done and we can clear it. We don't want to copy data around. Copying is expensive, especially on embedded devices that we use today, and especially now in upcoming times when 4K video and H.265 is prevalent, and it's going to be tons of data that we need to move on these little devices that have very weak CPUs and very weak GPUs and have very specialized hardware for video decoding and rendering. So we need to basically streamline the process to be able to decode a video frame, put it in a buffer, display it, remove it, and then it's done. So I'm going to talk about how we do this, how currently it's done, and where it's going with that. So it's used already in a lot of proprietary methods, but in using these proprietary methods, it's got all these issues where you can't actually, a lot of the times you don't actually know what's going on internally. There may be bugs, it's hard to fix things. These are just some examples, there's a lot more, but one of the ones that we deal with a lot is Amlogic, and their video decoding library is locked to the kernel 3.14, which is quite old by today's standards, so it is very difficult to use that. And it becomes a problem where you have maintenance on code, and it's very vendor specific, it's very hard to deal with. If someone that knows it is leaving, then you might be hooped because now no one knows how to maintain that or how it's even used. So where are we going? And so we're looking at a lot of open source solutions for this, and pretty much everything here is ready today. And so these are kind of the things needed, or the requirements needed in order to have your app or board have a zero copy pipeline. And so a Video for Linux 2 driver is needed, which is actually very common nowadays. There's a lot of movement in the Linux kernel for V4L2 stuff, and so we're really happy to see that. There's a lot of support. I'll be going over some of the support for different various boards a little bit later. There is still a little bit of an influx in the V4L2 subsystem with some stuff right now, but hopefully that will get merged pretty soon. It's dealing with the request API. It kind of just changes some stuff about how it actually works. But so, and then the next two aren't exclusive. If you wanted to, you could completely write your app using just the DRM driver if you don't have need for GL at all. And it's a really good method, but there are some limitations, and it depends on your app, because a lot of times your app may be a GL app, and it may have overlays that you need to use with the video and whatnot. So we are using these together. And so with OpenGL ES 2.0, there are some extensions that are needed in order to be able to use this pipeline, but they are pretty common, and even with the hardware that uses Mali, typically these extensions are in there. So that's what I mean by a lot of it is already in place and we can use it. So this is kind of how it's going to work for us. So there's some different stuff you can do, and you can implement a V4L2 abstraction in your app directly. And I actually tried this before, and it was kind of a disaster, but that's when I turned to doing some of the stuff with FFmpeg. So GStreamer has full support for V4L2 using the various types. So in V4L2 land, there is 3 different types of buffers you can use. One where it just maps its own memory, one where you can point it to memory, and then one where you can actually import DMA buffers into it. And with FFmpeg, we are still kind of catching up a little bit, and I still have some patches that are in review on the mailing list to implement what we need to be able to do zero copy. And it's working a little bit different than how some people would expect it, but it does work. And so we're basically letting V4L2 allocate the memory for us, and then we are able to use some V4L2 calls to export that memory address and use that. So what happens here in a very basic term is that we have our compressed video frame and push it through the decoder, and in FFmpeg we then request from V4L2 to export that buffer, and it just hands us a file descriptor. So we take that file descriptor and put it in this little wrapper, and that file descriptor is just pointing at the decoded frame, and then that decoded frame can just sit in its memory space and stay there until we don't need it anymore. And it's a very basic overview, but that's more or less how it works and how it'll work on GStreamer and stuff as well. So this is now how do we actually take that buffer and display it. So if your app doesn't use GL, you can do it in this method. So we're able to utilize some of the specialized hardware on embedded boards that are able to handle YUV video formats and display them directly on the hardware. And so it is a requirement that the DRM driver does support this, but support is really good currently in the Linux kernel. And so what we actually do is, from the file descriptor of the video frame, we basically import that, convert it to a handle, add a frame buffer, and then add that frame buffer to your DRM loop. So we are in Kodi, we are actually using a atomic mode setting for this, and it is very interesting with some of the stuff we can do. So yeah, and then this is just a kind of an overview of how it looks. So with your DRM planes, some devices will have specialized planes that are able to have the YUV formats, and then there's some that may be RGB only. So you have to watch out for that with your app. So in Kodi, we run the GUI completely, typically on overlay planes, but as long as a plane can handle RGB formats, it's fine. And then any video formats are typically on a primary plane, or as long as the plane can handle YUV formats. And it'll always be like that. And so when you have video playback, basically we can completely disable the overlay plane and have really great throughput for the video pipeline. There are some caveats with this, though, where, yeah, it depends on your DRM driver support. And the only instance I know of is with IMX6, where there's actually no scaler built into the display pipeline chain. There is a scaler built onto the board, but it's not used in there. So that becomes a problem when you can't actually upsize or downsize your video frame to the actual output of your resolution. So, and then we actually have the GLES and EGL import, which does a very similar thing where we take the file descriptor, but we're actually importing it into EGL and displaying it from there. There's some good stuff with that, and if you have advanced shaders or other things, you can play with it that way. It is a little bit more costly in terms of performance, but that's just depending on the GPU on your embedded board that you're using, and typically they're not very powerful, so you'll tend to struggle with this. And that's a big part about doing direct-to-plane stuff, where you can actually skip the GPU completely. So I just wanted to talk a little bit about the Mali stuff, and because although we have all these great open source solutions and stuff, unfortunately we are still stuck with the Mali Blob that is used on some boards and Mali is, for those that don't know, is the basically OpenGL driver user space library that interacts with a kernel driver. And it's licensed from ARM to use on different boards. But there's just a lot of problems with this because it's licensed per manufacturer, and then even then they have to pay a licensing fee to get different versions of the library. So some companies may only want to support X11, but some might want to support Wayland or vice versa. And we basically need a library that will support GBM to do this, and GBM is what we're using to be able to create rendering surfaces. And now, it's not a hard requirement because you might be able to do it with kernel dumb buffers, but I've never actually tried, and I've heard that it can be sometimes very problematic to have your EGL context and using surfaces with dumb buffers. So we're sticking with GBM for now. And yeah, so it's just difficult to fix any bugs that happen. And if you do find something or need something changed or need a different version of the library because it can be locked to the kernel driver version, you have to go through your vendor to get a new library, and even then you're probably just going to be out of luck because, yeah. And so with this, there is some open source efforts underway for the Lima and Panfrost drivers, which has had some good success in the last little while. Last I know, the Lima driver can now run KMS Cube, which is a good start. So where it's not quite ready to be able to be in use for us, but hopefully in the near future, because that would be really nice to have that. So now just some board-specific stuff I'll run through. I think there's 5 or 6 different SoCs here, and like the varying layers of support that we have for them. So with Allwinner, a lot of people probably seen the recent fundraiser that they did with Bootlin to do the V4L2 driver for Allwinner hardware, and that is basically done now. They are still waiting on that request API to be merged, but that should be hopefully any day, I believe. And then we can support that. They do use Mali typically on Allwinner hardware, but otherwise everything is pretty upstream in the mainline kernel for that. So, and Amlogic, which has kind of been an interesting story over the last year or so. We're working really close with some of these guys, these 2 guys from Bay Libra, on this stuff, and a V4L2 driver has emerged in the last 3 or 4 months, I think, to be able to support for Amlogic, and it's working well. It's working really well. So we have some Amlogic hardware running on mainline kernel with a couple just of these out of stream patches, and are able to do everything we need. So it's really exciting because, yeah, Amlogic was locked to 3.14 for the longest time, and they decided to drop support for a lot of their hardware in some of their newer kernels. So, yeah. And so Broadcom and Raspberry Pi, for those people that know it as that, same thing. There's actually a V4L2 driver that has emerged in the last, I think, 6 months or so, and it's working really well. And unfortunately, it's still in the Raspberry Pi kernel repository, so it's not something that's mainline. I believe the author of it, who works at the Raspberry Pi Foundation, will be trying to get it upstream, which is really good. I don't know of any timelines for that, so currently in my testing, I've been using 4.14 because that's the Raspberry Pi's LTS kernel that they're using. So, and unfortunately, the Raspberry Pi, the VC4 open source driver, doesn't support YUV format imports in the GL driver. So you have to use direct to plane rendering for that. And not that it's an issue; it works great, but it's just kind of one of those things. And NXP hardware, so IMX6, it has really improved a lot in the last little while. So with all the guys working on Etnaviv, we have really great support for this now. And there is some downsides. It just depends on the hardware you have, but hopefully they'll be able to get some optimizations in for GC2000 hardware, which is IMX6Q and less, and GC3000 is Q plus, and which has great performance. So you can do both methods, rendering methods with IMX6. However, like I said before, the DRM driver does lack a scaler built into the chain, so you will you might have issues with that, and I did too. And there's some other issues where you have to, when changing video formats for the plane, you have to initiate a mode set, and it has to do some heavy lifting internally. So there's some issues there, but it is possible. And the V4L2 CODA driver that is for IMX6 has existed for quite a while in the upstream kernel. But there's some more patches coming in to really kind of optimize it as well. And Qualcomm support here is great. Everything's in the mainline kernel. It's for the Dragon Board 410, and it's been in there for probably a year now. I think I've been running on the mainline kernel, and it works really well. You can use either forms of rendering for it, and yeah, not much more to say for that. I have by the way, I have a demo of all this hardware in the demo room downstairs too. So if people are actually interested in like seeing stuff running on certain hardware, I do have instances of everything. And even with IMX6, I have a Quad Plus and a Quad device, so we can see how the actual stuff is working there. And then there's a whole bunch of other vendors. I do have some Rockchip stuff as well. And Rockchip is hopefully going to catch up a little bit there, because as far as I know, the Chrome OS team and stuff is really pushing for the V4L2 driver from them. And I believe there is stuff started, but I don't know much more than that. And Renesas has a V4L2 driver and stuff too, but I just don't have hardware for that, so I don't know much about it. And then just some others too. So that's where we're kind of at currently. And this is just some information about where to get stuff. If people are interested in how we did this, or they're interested in seeing the actual implementation of it, and they want to review some code and see how we actually wrote it, these are some good links there to the actual tree for Cody and how we are actually doing this. And that's my presentation. So if anyone has any questions about this, I'd be happy to answer them. I will also be down in the demo room, so you can ask me for a few hours if anything comes up. But yeah. Do we have a mic here? Not sure if it's on, but.
So you did mention about the two paths, the direct-to-plane rendering and the OpenGL path.
Yep.
So comparing with the direct-to-plane rendering, if you have to adapt the OpenGL path, you do agree that there is an extra phase of copying when the decoded buffer is rendered to the output buffer and then wrapped for the DRM pipeline.
So, sorry, just one more time.
No, in the direct-to-plane path,
Yep.
the decoded buffer FD will be directly given to the DRM manager.
Yep.
In the case of FB.
Yep.
But if you have to adapt the OpenGL path, there is an extra phase of copying involved by the GPU where.
So yeah, if the GPU has to access the memory, but this is the best possible path that we can have, where you're actually importing the DMA buffer into EGL itself. I don't have a good knowledge of what is actually happening in the background there, and it may vary hardware to hardware and driver to driver, but the performance is still really good. And I can show that later on in the demo and stuff as well, because we can switch back and forth between the two versions if you're curious.
Okay, my question was, since it's a 0-to-0 copy, I thought that is the price we are paying for getting the shader support.
Yeah, so I mean, it's a good point, but it's the only way you can do it if you are constricted that way. So the video buffer is still being in its singles place in memory. We're just referencing it from the file descriptor. So yeah, if there has to be some sort of internal copying with the GPU, or depending on how the GPU works with internal blitting to change it from YUV to an RGB format, that is dependent on that. But yeah, it is a good point though to bring up. So thank you. Anyone else? Going.
So I've heard rumors that ARM is now releasing a generic Mali Blob. Have you looked at that yet?
Not too much. I actually try and avoid Mali as much as possible, but it will be nice if that is the case, and its license is more open, because a lot of the Mali blobs are very similar. It's just they're licensed to their hardware, even though they'll work across platform.
It allows for redistribution, and from the people I talked to at ARM, it also works cross-vendor if you have a reasonable enough kernel driver. I just haven't had time to look at it, and I think they even include a Wayland version with the mini GBM.
Good. Yeah, I mean, it would be really great. It still has its issues with Mali where it's closed, you don't actually know what's going on, if you need to fix bugs, etc. But yes, it will be easier, and depending on the SoC vendor, because some are better than others at being able to give you a new version of the Mali library. So yeah, but we've had it in the past where we didn't actually have a Mali library for Amlogic or something at the time, and so we actually had to use a Rockchip version to be able to test it, and it works fine. It's just the licensing was very explicit that it can only be used in on its hardware for distribution purposes. So, but it was good for testing. So, thank you. Anything else? All good. So the question was if I have done anything with IMX8, and yes and no, because I do have an IMX8 board. I just have their developer board, and I'm actually very excited to do stuff with it, but there's just not much going on at the moment. A lot of the guys that are working on Etnaviv and will be doing IMX8 stuff are still kind of tied up getting some of the stuff in for IMX6 into Mesa and into the kernel. But as far as I know, they do have some stuff for IMX8, and hopefully we'll see that in the next 6 months or so, at least, to get something running. But with IMX8 also, the video decoder is a different IP than what's used on IMX6, so it'll require a completely new driver for that. And apparently documentation is there and everything, it's just the work has to be done. So eventually, hopefully. And because I look forward to IMX 8 with 4K video and H.265 and everything as well. So, yep. Thank you. Cool. Thanks so much, guys. Hope to see you.